Hi everybody. This first lesson of Unit 6 is a review of solving and graphing inequalities. So this is not any sort of new material, but this is something that you did last year, and this first lesson is going to be a review so that we make sure we know what we're doing before we proceed with the new work this year. You need to be taking good notes just like you would in class. You should have received a note sheet, and so go ahead and take notes just as though you would if you were in class. If the video is going too fast, just turn it off, pause it, and continue once you're ready. So before we proceed, I want to talk a little bit about what an inequality is and how to think about an inequality properly. It's possible that you learned something about inequalities in your past that has to do with an alligator. And if that's the case, I want you to put that right out of your mind forever, because the alligator situation can help you properly place an inequality symbol in between two numbers, but it doesn't do anything in terms of building your comprehension of what an inequality actually is or how to deal with it when you have an inequality statement that involves a variable. So what you need to focus on instead is knowing what inequality symbols mean and how to deal with them mathematically. So you need to take a look and see this symbol. When you see it, know that means is less than. And this symbol right here is greater than. That one is less than or equal to, is greater than or equal to. So you just need to, independent of those being in a situation with numbers, you need to be able to look at those and recognize what they are. It's important to read an inequality statement from left to right. That's going to help you understand the relationship. Read it left to right just like you would a sentence in the English language or like you would an equation. So this first one right here, 4 is greater than or equal to 9. That's how we would read that. A little bit less intuitive is how to think about this next one, but really, again, reading it left to right helps you out. X is any number less than 6. So you can think to yourself, any number less than 6. Oh, I know some of those, 5, 4, 3, 2. So that helps you understand how to read that sentence left to right. All right, so now example 1. We're going to write an inequality for each graph. You can see points plotted on this number line. Start at 0 and include all the numbers that are less than 0, -1, -2, -3. So you can see that 0 is included because it's plotted as a solid dot. Just like we're plotting a point, there it is plotted. So our possibilities here for what x could be are all the numbers that are equal to 0 or less than that. So we would write x is less than or equal to 0. The next one, you can see it's also a less than situation. It's all the numbers less than 3, but we don't get to include 3. There's what we call an open circle there to indicate this is the end point of all the solutions, except we're not going to include this one. So we make an open circle. So in this case, we're saying x is all the numbers that are less than 3, but we're not including 3. Example 1c, we've got all the numbers that include -3 and are greater than that. You can see anything to the right of it means it's greater, so in this case we would write x is greater than or equal to -3. All right, now we're ready to start solving. Solving an inequality, as you know, is just like solving an equality, except solving an equation, but it has a couple of different rules that we will come to soon. But you can start off thinking about it in exactly the same way. We want to isolate our variable. Here's x over here on the left. We'd like it by itself, and so we're going to subtract 3 from each side. So we would write x is greater than or equal to 5. Nothing earth-shattering there. I think you guys understand that pretty well. So when we go to graph it, we're going to say x is any number that's equal to 5 or greater than 5. So think to yourself in your head first, what are some numbers greater than 5? 6, 7, 8. So when you go to plot them, you're going to start with 5, and you're going to say, do we get to include 5? Yes, because it says it could be greater than or equal to 5. So we're going to put a solid dot right at 5. And now x is any number greater than that, so those are the numbers that move over to the right. So we're going to draw our line and put an arrow there. All right, example 3. 9x is less than -27. again, we want to isolate our variable, so we're going to do that by dividing this time, dividing by 9. We get x is less than negative 3. So, do we get to include negative 3 as one of our solutions? No, it doesn't say that it can be equal to negative 3. So we're not including negative 3. That's going to be our end point, but we don't get to put a solid dot there to indicate that that's a solution. So x is less than negative 3. What are some numbers less than negative 3? Negative 4, negative 5, negative 6, anything to the left of it. So we're going to show those solutions and show an arrow to indicate it keeps going. All right. Next one, example 4, 7 is greater than or equal to x minus 3. Again, we're going to isolate our variables, so we're going to do plus 3 on each side. We get 10 is greater than or equal to x. Now, we'd like to write it so that our variable is on the left. That's going to make it easier for us to understand how to graph it and put it in the proper form. So, what we need to do now involves the symmetric property of inequalities. Basically going to swap sides. We're going to reverse it, but it's important that when we do that, we need to retain the relationship between the number and the variable. If you read it left to right, it says 10 is greater than or equal to x. So think about that. What are some numbers that 10 is greater than or equal to? Well, it's greater than 9, it's greater than 8. So when we go to write it in the other direction, it's important that we write it as a mirror image of itself, as though we took the whole thing and just swapped it around like a mirror image. Whoops. So, let's think about it. Initially we said 10 is greater than or equal to x. So some of the solutions to that would be 9, 8, 7. And so now that we've switched it around, is that relationship still retained? 9, 8, 7, are those less than or equal to 10? Yes, so we've done it properly. So don't confuse this switching of the sign with the situation that we get into when we divide or multiply by a negative number, which we're going to explain in just a minute. Here all we're doing is reversing the sign because we've switched the sides of our inequality, and it's important to understand when we do that. All right, now we've got a number line here that's not working out for us, so I'm going to draw another one, and I'm going to put my own numbers on it, and I'm going to put a 10 there, and a 9, and an 11. All right, so go ahead and draw one for yourself as well. Less than or equal to 10 means we have a solid dot at 10, and going over there to the left. All right, example 5. Now, here we go. Here's that case that I was talking about. The one difference in terms of solving an equation versus an inequality is that whenever we multiply or divide by a negative number, which in this case we need to isolate x by dividing by negative 4. Whenever we do that, it changes the situation so that we need to reverse the inequality symbol to retain the relationship between the two sides. So in this case, we're going to divide by negative 4, and we're going to get negative 2, and so we need to reverse our inequality symbol to write x is greater than negative 2. Most of the work in this unit is going to have a blank number line so that you can write in the values of your solution. So if that's the case, if it's blank, you need to write in some of your own numbers. So we know we're going to need a negative 2. You need to write at least 2 other numbers besides that. You don't need to fill in your entire number line, but you need to have at least 3 numbers listed on your number line. So in this case, x is greater than negative 2, so we're going to put an open circle at negative 2 and go over to the right. All right, example 6. Here's another situation where we need to isolate our variable by, this time, multiplying by a negative. We need to undo negative 1/2, so we're going to undo that by multiplying each side by negative 2. So if we multiply or divide by a negative number, it's important to reverse the inequality symbol to retain the proper relationship between the two sides. So in this case, we get x is greater than 6. When we go to graph it, we're going to put at least 3 numbers on our number line. X is greater than 6. We're going to have an open circle 6 and go over to the right. Next one. Now, this is a little bit more complicated. Here's a 2-step inequality. Same procedure as when you're solving an equation. So the first thing we need to do is figure out where x is. It's on the right. What's along with it? How do we isolate it? And the first thing we're going to do is plus 4 on each side. And we get 10 is greater than or equal to negative 2x. We want to isolate x, so we need to divide by negative 2. If we divide by negative 2 on each side, that's the situation where we need to reverse our inequality symbol. So instead of greater than or equal to, we're going to have less than or equal to. So now we're left with negative 5 is less than or equal to x. Well, we don't want to end with our x on the right. We really want the x to be on the left. So now we're going to do a mirror image swap of what we have. So we're going to have x on the left and negative 5 on the right, and then take a look at it. If you look at that inequality symbol, the larger side is toward the x and the smaller side is toward the negative 5. So we need to make sure that that's the way it stays. The larger side is toward the x, the smaller side is toward the negative 5. So we've got x is greater than or equal to negative 5. So let's put some numbers on our number line. Greater than or equal to means we have a solid dot. Greater than means we go to the right. Example 8. All right. Lohita has $25 to spend at the bookstore. She will buy one math book for $13 and some bargain paperbacks that are on sale for $1.50 each. So we need to write and solve an inequality to determine how many paperbacks she can buy. Well, what we don't know is how many paperbacks she can buy, so that's what our variable is going to be. We want to say x is equal to the number of paperbacks she buys. All right, so what's her situation? Well, she's going to buy this math book for $13. We're going to put that down. And then what's she going to do? She's going to buy a bunch of paperbacks, and each one is $1.50. So to figure out how much she's going to spend on paperbacks, we're going to multiply however many she buys times $1.50. Well, however many she buys is being represented by x, so we want to write $1.50x. We're going to add that to the $13. Now what's the deal? She's got $25 to spend. So it could come out to be exactly equal to 25, but maybe it won't come out exact. She could decide she's going to spend a little bit less than 25. All we know is that it can't go over 25. So we need to write an inequality symbol here. Her amount that she spends needs to be less than, or it could be equal to $25. All right, so now we've created a very nice inequality to model that situation, and we can solve it to find out how many books she could buy. So we're going to first subtract 13 from each side. We get 1.50x is less than or equal to 12. Now we're going to divide by 1.50. You could write it as 1.5 or 1.50. Either one's okay. And we're going to get x is less than or equal to 8. So she could buy 8 books, and it would come out to be exactly $25, but she could buy fewer books too. She could buy 7 books or 6 books or 5 books and end up with some money left over, and that's okay. So we're going to write our final answer in a sentence. She can buy, whoops, proper spelling is important. She can buy at most 8 books. That's one way to phrase it. We could also write she can buy 8 or fewer books. There's a few different ways that we can phrase this, but you need to communicate in your phrasing that she could buy 8 books or fewer than 8 books. All right. All right, so what is our rule for solving inequalities? The main thing we need to remember that's different from solving an equation for solving an inequality is that we need to reverse the inequality symbol. Come on. When multiplying or dividing by a negative. We need to reverse the inequality symbol when multiplying or dividing by a negative. The rule for graphing is that when we have less than or greater than, we're going to have an open circle, what we call an open circle. If we have less than or equal to, or greater than or equal to, we're going to be able to plot that point and have what we call a closed circle. All right, now it's time to try it. So you guys are going to try this on your own. You need to stop the video, give this a try. If you want to try all 5, try them first, or if you want to go one at a time, it's up to you. So stop the video. When you want to check it, start it again, and I'll show what the answers are here. I'm not going to talk through them. I'm just going to write through them. All right, that's it. I hope you did well, and we will see you when you get to class next time to learn some new materials about inequalities.